Hello, everyone. Mr. Havel here. Today we're going to jump into our Chapter 4, Part 2 notes 4.5. Okay, so today we're going to talk about the graphs of sine and cosine. The cool thing is both of these are like just waves that go on and on forever. Okay, so um, we're going to check that exploration out. So I already filled out these tables for you just to save a little bit of time on this video. You're welcome to pause them, but you should definitely remember all of these. So like sine of 0, sine of pi over 4, sine of pi over 2. So you should definitely remember these, or at least refresh yourself on all the trig values for sine, cosine, tangent, cotangent, all that kind of fun stuff. Okay. So you can pause it and record those values that hopefully you've got, right? So there's a few different ways to graph these. So if these are a little bit different than what your teacher teaches you, that's totally fine. It's just another way, okay? So for me, my biggest thing that I teach is if you see these intermediate points like root 2 over 2, me personally, I'm not that great at graphing root 2 over 2. But if you notice, these ones, pretty much every other one is relatively easy to graph, right? Because they're nice, easy points to see. And so that's where I put all my focus, is on those points right there. Okay. And so if we go through and we actually, I don't know if I can, there we go. Plot these points. So for sine, this top one, it starts at 0, 0. And then our next point here comes out to pi over 2 up to 1, that amplitude of 1. Our next point right here is going to be pi 0. And then next point, 3 pi over 2, comes down. And then our final point, 2 pi, comes back to what we call the midline. This case happens to be the x-axis, but it doesn't have to be the x-axis. It might be moved up and down. Just like any other graph that you've seen, it's not necessarily HK, but it's the same exact idea as with HK. Okay, and so we connect these points, and it's a nice smooth wave. Now that is one period of the parent function for sine. Holy mouthful. Okay, so here our period for both sine and cosine, you'll notice, is going to be 2 pi. So it's, if you look on our graph, it goes, and by the time it repeats its pattern, it goes through a cycle of 2 pi. So then after this, it keeps going like this. It goes backwards like this as well, and goes on forever in both ways. But for a parent function, for sine, we go from 0 to 2 pi. Okay, and then it repeats itself over and over again. Cosine's the same idea, but this time instead of starting at 0, 0, it starts at 0, 1, and then goes down here. So pi over 2 equals 0, pi is negative 1, 3 pi over 2 is 0, and 2 pi is back up here at 1. So this one looks more like that. Okay, but if you notice, that right there is kind of the same as this right there. Okay, so they're just off depending on what it is, but they're typically, the parent functions are off by half a pi. Okay, and so same thing, our period for cosine would be 2 pi. And again, it repeats itself. We get back up here, and then it does like another U looking thing in both directions. And it can go on forever and ever. So my recommendation is kind of to learn this pattern. Okay, we're going to use this pattern quite a bit. So for sine typically starts at the midline. So it starts at the midline. And again, typically if it's positive, it goes up, midline, down, midline. So you could keep doing that. So midline, up, midline, down. Midline, up, midline, down. Okay. Whereas cosine, the parent function starts up first. It has the same pattern, but it just starts at a different spot, right? So this one has up, midline, down, midline, up, midline, down, midline, up, midline, down, midline. So it keeps going. So as long as you can remember that pattern, sine and cosine are not too crazy, and therefore we'll see later on secant and cosecant are not too crazy to graph. Okay, so sine starts at 0, cosine starts at 1, and they trade off there. Amplitude's going to be the height, right? So the height of the wave. The amplitude for sine parent function, again, starts at 0 and then goes up, midline, down, midline. It's going to do the same exact pattern here. So if I'm at 0, I'm going to go down, midline, up, midline. And that is 2 periods. Oop, missed that one. That one's 2 periods of sine. Cool. But the amplitude is this height, the y value. Okay. So what does it go up and down? The highest is going to be an amplitude of 1 for the parent function. Okay. So for the parent, we can do different amplitudes, which we'll see later. Okay. And then the period, this is how often it repeats itself. So the parent function for sine has a period of 2 pi, which we already talked about. You can check out this video for a nice explanation of that. Cool. Now, going through, I'm not going to dive too much into cosine when we get to this, because it's the same idea. Okay. So this is quote unquote, again, it's not HK, but it kind of does the same stuff. Right, so it kind of does the same stuff as our HK that you've seen a million times. So the A, that is our amplitude, right? So if the absolute value of A is greater than 1, then it's stretched. In between 0 and 1, it's compressed. And then if A is negative, that's where we get our vertical reflection, right? So for sine, instead of going something like this, our vertical reflection will go like that, right? So it'll just kind of flip over. Now a horizontal stretch and compress, we see this a little bit in Algebra 2 honors, but not hugely, but this is the horizontal stretch and compress. So I'm kind of moving these guys this way or this way instead of that vertical stretch. Now here, if you notice, that changes the period. This is our typical period, and we just do it divided by the b value. So the one that's right next to the x. Okay, and so that will change the length of the period. It'll make it shorter or longer or anything like that. And you'll notice the pattern that if b is greater than 1, then it's going to shorten my pattern. If b is between 0 and 1, it's going to lengthen my pattern, or my period, not my pattern. And then phase shift. Okay, so phase shift, this is like the h value, right? So kind of the h value in HK, right? And this one moves the start to end, okay? So it's going to move it left or right, just like your H did. So what you do is you take, sorry for all this extra writing, but you take the value that's inside the parentheses here, and you just solve it, aka set it equal to 0. And you'll notice we're going to add over the C, and then we end up dividing by B. And so if you notice, that's why it comes out to be C over B. Okay. Just be careful with that, because if there's a plus here, right, if there's a plus right here, then it would end up coming out to be negative C over B. Okay, so it's just solving that. And then the vertical shift, that's the last variable there, D. Okay, and that moves it up and down from the midline. Okay, but it still keeps that pattern of midline up, midline down, midline up, midline down. Keeps that pattern, at least for sine. Cool. Okay, so it says draw a segment, draw a segment to match each one. Okay, and so here, if you notice, this period is a little bit longer, right? Because remember, within 2 pi, before we were able to get an entire up and down, whereas this one's a little bit shorter. Whereas this one, so this one's got a longer period. This one's got a shorter one. Again, it used to be where we would do 1 like that, but this one's got a couple loops in there. And then this one looks kind of nice and normal, right? So I would start with this one because I know that I'm going to look for my b value, and there shouldn't be a b value because if you remember, period is equal to 2 pi over b. So if I don't change the period here, the b value, which is going to be bx minus c plus d. So whatever is next to the x. So if I want that to be a 1, I kind of want that right there next to the x to be a 1 as well. Okay, so that's kind of a quick way to look at it. So that's that third graph would be the first equation there. The other thing that you notice is out in front here. That's your amplitude. And if you notice, my amplitude goes up to 2 and down to -2. So that's another good giveaway. Now this is where I kind of talked about with the period, where if it's a whole number, okay, it actually makes my period shorter, whereas if it's a fraction, it makes it a little bit longer. Okay? And so here the period in this case would be 2 pi over 2, and so that would be pi. So what that means is I have to do my entire pattern of midline up, midline down, midline within 1 pi now. So if you notice here on the second one, we've got midline up, midline down, midline. So I completed my pattern now within 1 pi. So that's why this guy is this one. Now, through just some simple reasoning, we know that this one is going to be the first one. But again, what I would do is I would do 2 pi over b, which is 1/2. Solve that out, and so that's going to be 4 pi. So 4 pi, this whole thing's got to go midline up, midline. Well, I did half of it within 2 pi. So the other half is going to be another 2 pi. So we know that my total period is going to be 4 pi. Okay, that's one way to look at it. Nice. So let's do a few of these graphs. Okay, so the biggest thing moving forward right now, we're just talking about sine. So that kind of makes our life easy. But always pay attention to kind of what your trig function is, right? And so this one, as soon as you see as soon as you see sine, you should think of that pattern. Here, I'm just making up my own, but midline up, midline down, midline, right? So that's a sine. That's the parent function for sine, as long as nothing else is changed with it, right? Whereas this one has some transformation. So my amplitude is going to be the a value out in front. So my amplitude's 1/2. Okay. The period is going to be 2 pi over b. In this case, b is 2. So that is going to be pi. So it's going to shorten my period. Okay. And so what you're going to do, and what I like to do personally, is I kind of get these first 2 points on the outsides first. I know I'm going to start at 0, at least for sine, and I'm going to end 1 period later, which is shabam, right there, okay, of pi. Now, my next point is going to be right in the middle of the two. That one's also on the midline. So what's in between 0 and pi? Well, it's pi over 2, right? So those are the 3 there. Now this one's not reflected, so I know my next point is going to be right in the middle of those 2. So I know that's going to be pi over 4, okay, because that's between 0 and pi over 2. And that's going to be up an amplitude of 1/2. So I'm kind of shortening or making the wave a little less tall. Okay, and then the next one is going to be right in between these 2. And that's going to be 3 pi over 4. Okay, and so the amplitude in this case is -1/2. So I know the pattern of center, up, center, down, center. And so that's just going to repeat itself now. So halfway is going to be up. This one's back down. Halfway is going to be back down and back there. So that is my sine wave. So that would be 2 periods of my sine wave. Okay. I forgot to do here, I won't do this on all of them, but this is the dotted line for the parent function. Again, the parent starts here, ends at 2 pi. Halfway through, it's going to be at 0 again. Half of that, so I should say the first quarter is going to be up, and the third quarter here is going to be down. So that is my parent function in pink. Right, so that wave kind of got squished both horizontally and vertically. Nice. Okay, number 3 here, our amplitude is 3. My period, that's going to be 2 pi over my b, which happens to be 1/2. So my total period is going to be 4 pi. Okay. And then my translation here, my shift. So my shift here is going to be d at the very end. So this is going to tell me it's a positive 1. So that's going to tell me I'm going to go up 1. Okay. So that all that says is take your entire graph and have it go up 1. I'll do the parent function again. Shabam, shabam, shabam. Up to 1. Down to 1. Have it repeat over here. Cool. And that is my parent function. Okay, for sine. This one looks a little bit high, but maybe move it down a little bit. Okay. So now my recommendation is when you have a different shift where you're moving it up or down, is kind of make your own new x-axis. Okay. So that is my new midline. Okay, that's my new midline because I shifted everything up. Now from here, I can just base it off. I don't really have to think too crazy hard. I can base everything off of my new midline there. Okay, and so again, sine is going to start at 0 here. Right, so sine starts at 0. Now the tricky part is it says that my total period is 4 pi. And so there's a few ways that you can look at this. Number 1, we know that my next point where it's going to hit 0 and complete it is going to be way over here, right, at 4 pi. But then I know halfway is going to be back at 0, right? So I know halfway is going to be back at 0. And so if you work backwards, if that's 2 pi, so every 2 pi it's going to go hit 0. So 2 pi, 0, now negative 2 pi. And again, when I hit 0, I guess I should say hits the midline, right? So it hits the midline there every 2 pi. Cool. And now here, it's all dependent on, it might be if you're like, should this be going up or should it be going down? Maybe test one of them, right? So if I test this right here, right? So if I test pi, because I'm like, I'm not totally sure, plug in pi right here, right? And so if I have sine, and this is kind of as far as I need to go, pi over 2, right? What is sine pi over 2? Well, sine pi over 2 is going to be 1, and then this is going to be times 3 plus 1. So this tells me it's going to be positive, so it's going to be up. So this is going to work out to be 4. Right, so again, this is my green dotted line is my midline. So halfway between 0 and 2 pi, which is pi, I'm going to go up to 4. But if you notice, that's an amplitude from my new midline. It's an amplitude of 3. So going the other direction between 0 and negative 2 pi, which is negative pi, I'm going to go from my midline down my amplitude, which is 0, 1, negative 1, negative 2. So that right there, folks, is my stretched vertically and horizontal and a shift up sine graph. Whew, that's a lot. Okay. All right, let's try one more. These, in my opinion, are definitely the most challenging when we have a phase shift. So the phase shift moves it left and right. Okay, so it's going to move it left and right. And so that makes it a little bit tricky because that 0 value now moves. It's not at 0 anymore necessarily. Okay, so my amplitude is 3. My period still is going to be 2 pi over b. So that's going to be pi. And now the phase shift, remember, you just solve what's in the parentheses. So 2x minus pi is equal to 0. Add over the pi, 2x is equal to pi. So x is equal to pi over 2. Now, which direction does this go? Well, whenever you solve it, it's whichever sign you come out with. So it's positive, so that tells me that I go to the right. Okay, so I go to the right pi over 2. So there's a bunch of values here. So I've got a vertical stretch here, my period, so I've got a horizontal compress, and then my phase shift. Holy smokes. Right? And so kind of there's a few ways to look at this. So we've got this is pi. This would be pi over 2 and 3 pi over 2. Oops, pi over 2. Pi, and I just split it because I wanted to, my phase shift is pi over 2, so I wanted to make sure I had that point right there. So now if you notice my, I'll do a different color just so it stands out a little bit. My phase gets moved over, so this is now my initial point right there. Okay, so there's a few ways to look at this. So what I like to do is I will go here, that's my initial point because of my phase shift. So my next one is going to be pi, I guess my final point will be pi away. Well, pi away would be at 3 pi over 2. Now the value right in between, we have it. And then these guys, I'm going to kind of make little tally marks right in between those guys. You know, for sine, it goes up first and then down. Right? And so that right there, that is 1 period. Okay, so it says graph 1 period. So this is technically correct. Okay, now this is where it gets a little bit tricky of where it should go. Typically your default is you want to kind of center the period as much as you can around the origin. Okay, and so if I work backwards, if I go pi over 2 and then subtract pi, I end up at negative pi over 2. So that's another 0. Well, in between negative pi over 2 and pi over 2 is 0. So that's my other midline. And so this is, you start from left to right. So we're going to go up 3, down 3. Okay. And again, this is another period, but it says use 1 period. So typically what you will see, this one on the right's not wrong because it is 1 period, but typically what you'll see is you'll see it kind of centered there about the origin as much as possible. Okay. And so we'll bring it right there and show that period right there. Cool. Okay, cosine, again, I'll cruise through this one because most of it is the same. It's just got a different pattern, right? So instead of starting at 0, 0, we start at 1. My endpoint is at 1 as well. In this case, my middle one is the opposite. And then these quarter ones are at mid-9. Okay, same thing here. So it's kind of up, midline, down, midline, up. Another way to look at it. I want to reiterate that you guys are going to see a bunch of ways to graph these. So there's ways that you can set up tables, all kinds of stuff. So if you're confused with this, practice it a few times, but then you can ask your teacher for the ways they do it. Check out some YouTube. There are a million different ways to graph these guys. Okay. Amplitude of the period function, again, is going to be 1. Period is 2 pi. Now going through, again, I'm going to cruise through this one because we've seen it. You'll see same behaviors as our with cosine as we saw with our sine. So same period, phase shift, vertical shift, amplitude, that kind of stuff. Okay, so let's check it out. So a few things that you want to notice is here, this number one kind of looks like a sine, right? So it kind of looks like a sine function. And so I do see a sine function. So sine starts here, ends there of 2 pi, and it goes up to 3. So that kind of looks like that, right? So that's that guy. Now here, one thing that you'll notice is, if you notice on this one, the midline has changed, right? So the midline's changed. It's no longer along the x-axis. So that would change the midline. And then here, this is a vertical reflection. So instead of starting up at positive and going something like that, we are starting down at negative and doing the exact opposite. Okay, so that's going to be your vertical reflection. And this one here, if you notice, if I draw the midline at -3, it starts up 1, middle, down, middle, up. That's that pattern for cosine. Okay, so that is a change in the midline. All right, let's do a few of these graphs here. And then we do have some multiple choice on the next pages that can go a little bit faster through here. Okay, so here, amplitude. When you look at amplitude, don't look at -3. So the amplitude is 3. Down here at the bottom, reflection, yes, there is a reflection. Okay, so this is the reflection, this is the amplitude. Period is the same idea, is you're going to do 2 pi. Now this one's going to look really weird. So 2 pi over the b value. So that's pi over 2. What in the world? Skip, flip, and multiply. So you have 2 pi times 2 over pi. So these are going to cancel and leave you with 4. Okay, so my whole period is 4. That's okay. It doesn't have to have a pi in there. Okay, and then a shift here. If you notice, there's no parentheses, so I definitely don't have a phase shift, but my vertical shift is down 2. Okay, because of that d value there. So the first thing I would do is I would move my midline down here to -2. And then from there, with cosine, since I don't have a phase shift, you know at 0, right here, we're going to start up, right? But we do have a reflection. So since the reflection's there, we start going down. So we go down 3 from this new midline. So 1, 2, 3. So that's going to be my starting point there. Okay. Okay, and so here, the same idea is we're starting at 0. So I'm going to end at my period 4. So I'm going to end at the same spot. And so cosine typically is you start at pi and then midline down, midline up. But since this is reflected, we're going to start low and then midline. And then halfway through, I'm going to be up from the midline. I'll be up 3, so it turns out to be 1 right there. A third of the way, or 3/4 of the way back to midline. Okay, now I can work backwards here. We should be midline up, midline down. Nice. Okay, a lot of times you'll want to read here if it gives you the restriction or says 1 period or do the entire graph. If it says do the entire graph, do as much as you can until you run out of the graph. Okay, nice. This guy here, amplitude 3/2. Okay, so 1.5. My period is going to be 2 pi over b, which is 4. That simplifies to pi over 2. Okay. And then the phase shift, we solve out the parentheses. So this is going to subtract the pi. And so x is equal to -pi over 4. Cool. And so again, there's a million ways to go about this one. But what I would do is I would do my phase shift. Okay, so we don't have a vertical shift or anything like that. So everything will be kind of on our x-axis there. So my recommendation is that we are going to find our starting point. So I'll do here, this is going to be negative pi over 2. This would be negative pi over 4. This would be negative 3 pi over 4. Okay. Now, again, it says here, it says graph one period of it. So we're not going to do the whole thing. So my recommendation is this phase shift, that's going to be my new starting point. So for cosine, my starting point is now right here. So what's going to happen is I'm going to go up my amplitude 1.5. Cool. Now my ending point is going to be negative pi over 4 plus my total period. Well, my total period is going to be pi over 2, so I'm going to add pi over 2. And so my ending point here is going to be positive pi over 4. So that's going to be my ending point. Okay. So as long as you know cosine right in the middle, even though my points are a little bit off, right in the middle of negative pi over 4 and pi over 4, that's going to be your low point. So right there. And then the 1/4 of the way and 3/4 of the way is going to be your midline. Okay, so that right there, that's your graph of cosine with all the transformations. Now it also says, okay, we'll do the parent function just so that we can see the difference. So our parent function is going to be dotted. Now remember, our parent function for cosine, right here, pi doesn't give us enough space. Okay, so this is going to be a little bit different. At 0, it's 1. Now typically at 2 pi, it's 1 again, but in this case, my pi is going to be halfway there, and so that's going to be down. This right here is going to be in the middle, and so we kind of work backwards. So this is going to be pi over 2. So negative pi over 2 is going to be 0, and then negative pi is negative 1. Cool? Okay. Cool. So hopefully that helps you with your graphing right there. Okay, so a few things here that we're going to cruise as much as possible is we are going to check out. So I would kind of cruise through here and just look at each individual one, right? So that right there, that tells me that I have an amplitude of 1/2. So if I look through, oh, here's one. Okay. Oh, wow, that looks weird. Okay. I don't know. So I would pause on that because that looks weird to me. But the only thing that would change my amplitude or how high things went would be this last value, D, right? So if I had a graph like this, what's going to happen is at 1, that's going to be my new midline, thanks to this guy, right? And then here, thanks to my amplitude, it tells me that I'm going to go up. So if this is at 1, this is at 2, I'm going to go up 1/2 and then kind of middle down 1/2, middle up 1/2, right? And so that just a super rough sketch of what it looks like. So it looks like, okay, that makes sense. So this is 1.5 and this one down here would be 0.5. Okay. So this one makes sense here. E makes sense. F does not because I don't go that low down. Cool. Now period is going to be 2 pi over b. So 2 pi over 3. Okay, sweet. It's right there. That one doesn't work right there. It says here vertical shift up 1. Well, yeah, we just checked that out. That one works. And now a phase shift. So that one is a really easy one to recognize because remember phase shift will always be inside of parentheses. But I don't have parentheses there, right? And so I don't have a phase shift. So that one would be wrong. Cool. So as you could tell here, I started going through here, did the amplitude, and like, I would have initially guessed F, but I'm like, oh, 1.5 looks weird. So I had to do a couple things and do kind of a rough sketch for it to make sense to me. Okay. It says choose the right graph of g of x, which is the one that we're talking about up here. Right, so the first thing I would look at is that vertical shift. Okay, so of 1. So this one looks pretty good. This one doesn't look pretty good. This one, pretty good. And this one, not pretty good. Right, so again, they should all be centered about that midline. I'm going to write it here just so I don't have to keep coming back. So this is 1/2 cosine 4x. Oops, nope. Cosine 3x plus 1. I was looking at the wrong one. Go away, go away. Cosine 3x plus 1. So now, then again, the next thing I would do that would be an easy solve is look at this, make sure my amplitude. So here it went up 1/2 and down 1/2. Cool, I still like that one. D, up 1/2, down 1/2. Oh, man, I was hoping that would help me. So that didn't help me at all, right? And so the amplitude didn't. So now we already solved it, but my period is going to be 2 pi over 3. So that tells me within 2 pi over 3, I should have a complete cosine graph, right? So if I look here, 0, 2 pi over 3 would be like here, right? So did I complete an entire u within right there? No. So if I look right here, 0 to 2 pi over 3, holy smokes, I got that u value that I'm hoping for. Okay, so that would be D there. So definitely go through, try to eliminate as much as you can, and don't just guess on these guys because they do take a little bit of thought. Nice. Now this one doesn't have to be, but if you look, my first thought would be sine because it starts at 0. Now the only way a cosine graph would be a sine graph is if there was a phase shift. Well, if you look in here, yes, there's parentheses, but there's no C value, right? So there's no C values on C and D. So it cannot be a cosine graph because there's no phase shift. So adios, adios. And to make it really easy for it, not really easy, never mind, I thought it was. Look, my amplitude's 3, so that doesn't help me with B or D. So the only thing that's going to help me is that final period. So I want my period to be 4 pi. And so I'm going to have 2 pi. I don't want to do it divided by 2 because I know what that's going to come out to be. So I'm going to do it divided by 1/2, which is this guy. And so that comes out to be 4 pi. So I get a total sine graph within that 4 pi. So D again. Nice. Okay. Same thing here. You're going to look at it, and the first thing I would look at to help eliminate is the D value there. So it's definitely not -3, right? Because again, the midline has to be right in the middle. So I know -3 is not going to help me, right? So anything with -3 is out there for the midline. So adios, adios. Now cosine, okay, that doesn't help me. Oh, this might help me, right? So at 0, and my midline here is at -1. Again, at 0, typically cosine goes up. All right, so typically cosine starts positive, but this time it goes down. So that tells me that I want that reflection. So that's going to be B. All right, last but definitely not least, it says write at least one equation for the function below. Now, you can be the hero and write a bunch of them, but make it as easy as you possibly can on yourself, right? So one thing, you kind of want to go through and answer all of these values, right? So A, without giving it away, sine or cosine, I'm going to say sine bx minus c plus d. So you need to solve each one of these. So the reason, without giving it away too quickly, I picked sine is because it starts at 0, 0. Okay, so I'm going to make this as easy as I can on myself. You could do cosine, but you would need a phase shift. So since I told myself that I'm starting here and it's a sine, that means there's no phase shift. So that means that C is gone. Okay, and now how high does my graph go from midline? It goes up 4 and down 4. So my A value is going to be 4. It's not -4 because it follows the sine pattern that I know. Okay, again, it's on the x-axis, so I don't have a vertical shift, so D is gone. And so I just need to figure out B now. Now, you can guess and check if you want, but I know my 2 pi over B should equal 1 full period, which is going to be, in this case, pi over 2. Right, so we can solve this out. So I have a pi on top and bottom, so I'm going to cancel that out with that. Multiply the B over. And so I'm going to have 2 is equal to B over 2, and multiply this 2 over to get rid of it. So B is going to equal 4. So this is going to be sine 4x. Cool. Again, there's an infinite number of equations that you can write for this one, but that is kind of the easiest one you can do. Cool. I hope you guys enjoyed. Stay tuned for 4.6, other trig functions. Adios.